All right, let's get started. Let's do the weekly contest 391. I think this is going to be quicker than previous contests. So let's get started. Q1. Harshad number, an integer divisible by the sum of its digits, is said to be a Harshad number. You are given what is this name? Never heard of that. Smart coder, welcome. Never heard of a Harshad. Is this like an internal LeetCode reference? Oh no, it seems like it's a legit mathematical thing. Probably LeetCode is hiring more Indian writers. Yeah, could be. You are given an integer x. Return the sum of the digits of x if x is a Harshad number. Otherwise, return -1. Okay, so here the first, this is pretty straightforward. So for example, for 18, the sum of the digits is 9, and it divides 18, so you have to return 9. But here, the sum of the digits is 5, and 5 does not divide 23, so you return -1. And the numbers are even small. They could be big. They could be big. But they want to make it extra easy for us. And yeah, notice, so I was thinking, because the sum of the digits could be 0 for number 0. And in that case, you cannot divide. You cannot. Hey, Lucia, welcome. Legend. Thank you. All right. So, yeah. So x cannot be 0, which was my question, because you have to be careful with division by 0. So now let's have a nice function that gives us. So one thing that I like to do is to use Python's yield feature. So the way to get the digits of a number, we yield the digit and then we divide by 10. So that's going to give us the digits, and then we can just call sum of digits of x, and we have, hey, thanks for the follow, Has. Okay, so then we just write this and we get the sum of the digits. It's a little more flexible this way. I mean, you can just add them here and return them, but this is a little sweeter, I think. Anyway, so let's call this the sum of the digits. Let's call it x. And so if x is divisible by s, we have to return s. Otherwise, we return -1. I think that's what we are asked to do. Let's see. We pass the examples and we got accepted. Cool. And this is only 50%. Anyways. Yeah, not much to say about this one, I think. Easy for you. Yeah, I think, I don't know how many. Yeah, it's pretty straightforward, I guess. Anyways, let's go to question 2. I'm sharing the link. Can you show us the reduce solution? Oh, the reduce? Uh, what do you mean the reduced solution? Map reduce. No, I don't know how I would do this with the reduce function. I guess another option. So yeah, another option is to use the string function. So you transform this into a string and then you map. Yes, there is a reduce function and a map function. So yeah, so you can map int to a string, and that should give you the sum of the digits, so you don't need this. I guess this is what you meant. Something like this. Yep. This, yeah, this should work too. I usually try to avoid transforming into strings, but I think sometimes it's the easiest. Reporting for coach 20-minute stream. Yeah, I think this is going to be a short one. Anyways, I'm doing multiple solutions, so maybe not, because Smart Coder. I'm not complaining about the questions. I welcome them. So I usually try to avoid using strings or converting numbers to strings. I like to deal with the digits by dividing and taking the mod. But yeah, sometimes I think it's the code is shorter by doing the conversion to strings. Anyway, so this problem, water bottles 2. What? So is there another water bottles? I guess I haven't seen that one. I don't think. So yeah, so in one operation you can perform one of the following operations. So it's weird that in one operation you perform, okay, so one of exchange, but don't you do, I think you do both of them. Anyway, so drink any number of full bottles, water bottles, turning them into empty bottles. Exchange empty bottles with a full water bottle. Then increase num exchange by 1. Know that you cannot exchange multiple batches of empty bottles for the same value of num exchange. Return the maximum number of water bottles. So here I think this is a little confusing, because they make it seem like there's some kind of optimal decision that you have to make, but you always want to drink all the bottles that you have, and then you exchange them for full bottles. I mean, there's no decision to make. There's only one thing to do. I mean, there's no penalty for drinking the bottles that you have full, and then the only thing you can do is exchange the empty bottles. So I think this is a little confusing on how, and this is small, so we can just simulate this process. Also, notice that at the beginning you have some number of full bottles, but then you make an exchange and you get only one full bottle. So it's like the first Yeah, I don't think it's tricky. It's more that the statement is this, the description is not well explained. I mean, it's confusing. So here you can just first we drink all the bottles, right? And now our bottles are empty. So now we want to know if we can exchange them for a full bottle. So if we can exchange them, if we have the number of bottles that we have, they are all empty. If they are greater than or equal to num exchange, then we're gonna exchange them by this number of bottles, but we then get one of them full. So we subtract one from this. Then we count, we drink this one, so we count one more drink. And then we have to increase the exchange rate by 1. And I think that's all there is to it. You just do what you're told, and that's it. Nothing. Harder version problem. Minimum initial energy to finish tasks. Okay, I'm not gonna do that one right now, but yeah, if anyone is interested. So yeah, so this is pretty straightforward. I don't think I think the difficulty is to realize that the explanation is bad. So this one, count alternating subarrays. You're given a binary array nums. You call a subarray alternating if not two adjacent elements in the subarray have the same value. And you're asked to return the to count the number of alternating subarrays in nums. So this is, so what I did here, and the size is 10 to the 5, so you cannot do something quadratic. So the first idea that came into my mind when I saw this was to think about the sliding window. But I know it's not necessary. This is a simpler kind of problem, but I just coded and the code was simple and I got accepted quickly. So so let's just do a standard standard sliding window. So we are now our window. We want to know how many subarrays that end at R. So now that we added R to the window, we want to check. We want to shrink the window while it is not valid. Okay, and what does it mean for it to not be valid? The text is too small. Oh, sorry. What about now? By the way, welcome, sudo please. Okay, so here we want them to be equal depending on the parity of the length. So if they are not equal, so for example, if L is equal to R, then the length is going to be 1. And in that case, we want them to be equal, right? Because they are the same element. They must be equal. But if they are not, we increase, we shrink the window, and then we just add the size of the window, because those are all the subarrays, all those beginnings, subarray count, and so this is it. Is it better this right now? All right, so here's my submission, and now let's go to the last one. Minimize Manhattan distances. You're given a zero index array representing integer coordinates of some points on a 2D plane. The distances between 2 points is defined as their Manhattan distance. Return the minimum possible value for maximum distance between any 2 points by removing exactly 1 point. Okay. And you have 10 to the 5 points. So you can't do a quadratic algorithm. You can't do all pairs. You mentioned you had a simpler non-sliding window approach, but it was a sliding window approach. Yeah, this is, no, what I said is that I think you can simplify this. And hey, Haz, thanks for the subscription. Thanks a lot. I appreciate it. So what was I saying? Yes, what I'm saying is that I think there can be, you can simplify this and avoid having 2 loops, but I didn't bother. I think this is simple enough, and it's the template that I use, so I didn't think about how to simplify this. So this is my solution. If you have a simpler one, you can share it. It would be interesting to see. Anyway, so going back to Q4. So yes, you cannot do an all pairs type of algorithm because the number of points is 10 to the 5. So the pairs would be 10 to the 10, which is a lot. Hey, Midnight Simon, welcome, welcome. I'm doing a short stream. You always tell me to do longer streams, but I think this one is going to be short because of the contest. I don't think I have too much to say about the problems. Let's put it that way. So for this problem, so there is a trick that is well known. You can do cock. Yeah, maybe not another string. But you. Let me see. Oh, I think this is getting moderated. One message was moderated because because Smart Coder said 3 ways, which I think it was misinterpreted by the automod. How can you say that, Smart Coder? No, I'm gonna cover. So I think this stream is gonna be short because I'm just covering my solutions. This time I usually sometimes do more than one, but in this case I'm not. Anyway, so there's a well-known trick in competitive programming for so if you do a transformation, so notice that when you well, wait a minute, I'm turning on my tablet. So notice that when you have points in the plane, what's up, AK star? Sir. Anyway, so what you can do, so notice, for example, if you have one point in the origin, so notice that all the points that are here are going to be the same distance to, right? So for example, if this is at 3, then this point is at distance 3, that Manhattan distance, right? This is distance 3. And this point, which is at 3, is also at distance, but this point here, that is at 1 and 2, it's also distance 3, right? Because you add the delta. So here you have 2, you move 2 up and 1 to the left. So all the points that are on this line are at the same distance, right? And you can and this is the same here, and this is the same here, and this is the same here. Hey Pat, welcome. We have the popular streamers are here. If you don't, you should follow Pat. His streams are very entertaining. Let's say that. Let's put it that way. Anyways, so what I was saying. So I'm trying to motivate why we use this trick. I don't have a very deep explanation, but if you think about it, so what I'm saying is that all the points that are here and then all the points that are here. So notice that this suggests you love problem solving. So notice that this is suggesting some kind of rotation, right? Because this is a square that is if you rotate this is a square that is rotated, right? So what if we rotated the axis so that it is aligned with this squared, right? So it turns out that you can do that by just changing the coordinates. So if you have point x and y, you can transform it into point x plus y and x minus y, and this does this rotation, okay? And it turns out that so the Manhattan distance here was, so if you have 2 points, the Manhattan distance was x1 minus x2, the absolute value, plus y1 minus y2. But this gets in this transformation, did you end stream undefeated against LC problems? Okay, so here it turns out that now the distances between the points is well, it's the maximum, sorry. It's the maximum. The maximum of this instead of the sum. So you have x1 minus x2 and y1 minus y2. And why does this matter? Well, now you can think about the distances independently between x and y coordinates. If you have, so in this new system, once you do the transformation, so let's say you have a point here, you have a point here, so you have all your points in the plane, okay? And so and let's say, so this is the minimum x, right, of these points, and then this is the maximum x. So this is the x coordinates, this is the y coordinates, and here you have the maximum y. So you can bound all the points with a box, with a rectangle. And notice that since the distances now are the maximum deltas on each dimension, now here the maximum distance is just going to be the difference between the maximum x and the maximum, well, in this case where this is a rectangle that is longer along the x axis, then the maximum x minus the minimum x is going to be the maximum distance of all this of all the points, right? So now it is obvious that if you want to reduce the maximum distance, so it doesn't matter. It doesn't matter if you remove an internal point. It's not going to make any difference, because this is the point and this is the point that these 2 points are the ones that are at the maximum distance, right? So it is important. So these are the critical points here, this and this. So in order to make the maximum distance smaller, we have to try removing it only makes sense to remove this one or this one. Those are the only options. So we can try that. We can try removing this one and removing this one and see what the new distance is, and we get the minimum of those, and that's going to be our answer. Okay, so, and notice that if there was another point here, so if there was in this line there was another point with the maximum x, then in that case it doesn't matter which one you remove, because whatever, if you remove this one but this stays here, then you're not gonna reduce the maximum distance. The maximum distance is the same. So you're only making a difference when there's only one point. So in that case, there's only one point, so there's no choice. And so with that in mind, we can make a pretty concise solution here. So we want the x's. Now we do the transformation. We said that the x's are going to be x plus y, and the y's are going to be x minus y. Okay, and then notice that I assumed in my diagram, I assumed that this was a rectangle, so the distance along the x-axis was greater. So that's why I focused on the x coordinate. But it could be that you have a rectangle that is taller than wider, and in that case you would remove the maximum of the y coordinate and the minimum coordinate, y coordinate. Okay, so we can just check if the maximum from the x. So remember that this is the So this is the distance, the maximum distance along the x-axis, and we compare it. If it's greater than or equal to the maximum distance along the y-axis, then we want to make the change. We're going to have a function that's going to tell us what the minimum distance is. Let's call it min dist. And then we're going to reuse that function here in the case that where we want to remove the point with the maximum and minimum y coordinate. But we're gonna swap them so that in the function we're gonna focus on the first coordinate, and we can reuse it. Okay, so this is going to be min distance, and so we want let's sort it so that we have access to the minimum, the maximum, and the second minimum and the second maximum. We want to have access quickly, so we can do this in Python to sort this parallel arrays with zip. So now we have them sort by the x coordinate. And so now we have two options. We remove the first point or the last point. Okay, so here, and we're going to take the minimum. So let's say this is R1. So here, let's have a comment. Remove first point. And here, remove last point. And in the end, we're going to return the minimum of the two options, right? This is going to give us the max distance after removing the point, and we want to get the minimum of those two options. So now we have to compute so we want to remove the first point. So now the distance, it's going to be the maximum in the x coordinates and the max and the y coordinates, the range. So here, this is the last x coordinate, so the maximum x coordinate minus the second x coordinate, because we're removing the first point, remember that? And then we want the maximum of the y coordinates, removing the first element, minus the minimum of the y's coordinate, also removing the first element. And so this is going to give us the maximum distance removing the first point. And here we can do something similar, but here we want to remove the last point, so now the maximum is the second to last, and here the minimum is the first, and so here we remove the last, and here we also remove the last element. And so this should give us, so it passes the examples, and we get accepted. Cool. So here's my submission, and like I said, well, it's not a 20-minute, but it's kind of short compared to other streams, other contest streams. Why not complexity analysis? Yeah, I can do that, of course. In this case, so here, so I have sort. So this solution is n log n, but it is not necessary to sort. So I do it for convenience, because notice that I'm trying to access here. So I'm trying to access here the first element, so the minimum, and the second minimum. And here I'm accessing the maximum, and here I'm accessing the second maximum. So that's why I sort, but you don't need to sort to get those four values. So you could do, I mean, does it make sense for me to do that? So there's a function in Python which is called n largest and n smallest. So I could call it n smallest of 2 and get the first 2 points, the 2 smallest points. So yes, the space is O of n. I'm creating this arrays, these lists, with the transformed points. So that means, and here I'm even creating copies for sorted copies, but that doesn't change the order of complexity. It's of O of n. But my point was that this is n again, but it doesn't have to be. It could be O of n, but the code would be more complicated. So so in a contest, you would rather have a simpler code that you can code faster and not have the best complexity, especially if there's a difference, if just a log difference, which in practice is usually negligible. And so in this one, this is a typical sliding window pattern. So this is linear because this loops executes a number of times of the length, and this loops increments L each time. So it also can be executed at most the number of times of the size of the array. So, but yeah, thanks for reminding me. Sometimes I skip the complexity analysis because I think it's simple, but yeah, not always. You're right. For example, here there was an important point about the sorting, the logarithm. So thank you for your question. All right, so that's all I have, I think, for now. So thanks for your support, guys. I appreciate it, and maybe we'll see again. I'll see you again tomorrow. I use LC for interview prep, but not for competition, so I always do it. Yeah, that's fair. That's good. Yeah, I should do it, definitely. You're right. What I'm saying is that, so even in interviews, definitely in real life, you don't always want the best order of complexity. Especially in theory, right? Sometimes there's a trade-off between the simplicity of the code, the maintainability. So I argue that in this case it could make sense to do this even in an interview. and then you can explain why you made that decision and what you could have done, or what other an interesting discussion with the interviewer, and that also demonstrates that you're knowledgeable and you make the decision. You didn't make the decision lightly. You understand what the trade-offs are. So take that into account. You can explain these things. It's not just in an interview. It's not just the code. I mean, it's also what you can explain and you can explain to the interviewer. Anyway, so thank you very much, guys. See you in the next one. Bye bye.